Timing and spacing are correlated in animation. Traditionally, it refers to the number of frames given to an action. For example, in how many frames does an object travel from one place to another? It could be a complex motion like a hand gesture or a head turn, or it could be a simple motion like just a ball rolling from one place to another, okay, or a paper falling down, okay. The individual timing given to an object can define its characteristics, its personality, okay. Like if a balloon is falling on the ground and at the same time you throw a solid bowling ball on the ground, what will hit the ground first? What will be the timing of both the objects? You can see in the example above that the balloon falls, even though the animation is of the same length, the balloon falls later on, and the bowling ball falls hard on the ground and settles before it does. So it is the different spacing and timing is given to different objects, and you should identify that based on the material properties of your object or the intended motion of your animation, and use that timing, physical timing, to make it look right. So here let me show you basics of timing, the base how the timing works, okay, and how timing and spacing can correlate. All right. So here we have two balls and two uh, objects here who will be animated in about a second, which is 30 frames. Okay, so frame rate is it could be 24 frames per second, 25 or 30, depending on it could be anything really, but these are the standard frame rates that we usually work in. Okay, we will animate both of these objects moving from point A to point B in 1 second itself, okay. Only the exact timing they will have, the total time will be 1 second, but the variation that we will do in its spacing will define its properties, okay. So that's how timing and spacing will work together. Okay, so let's see, let's go to the last frame and make both our objects go from here to here. Okay, it's just a simple animation, simple example. Okay, so they're moving from one place to another, and we haven't done any ease in, ease out, or any other principle on them really, and it's not interesting right now, but this is just to show you how timing works. Okay, now what we have to do is, if I select this object, you can see how each frame is distributed. What is the spacing between let me zoom in. What is the spacing between each frame? Okay, if this is the anchor point, what is the spacing that each frame has? And what if I move this object a bit further away in between? All right, and the key will be automatically set, but now you can see that I have increased the spacing that it was before. Okay, this space between two frames is the spacing, and it in turn will affect on what the timing is, because the farther the spacing is, the faster the object will travel, because within those frames you are giving it within that time, within 4 frames, you are increasing the spacing of it. All right, so now you can already see that it's quick at the start and then go slowly, because it has more frames in this time frame and has less frames in this time frame. So the less frames means bigger spacing. Okay, it's a little bit confusing, but once you really do it, it's pretty easy. All right, so let me just remove that. We'll do something drastic so it will be much more visible. All right, so let the spacing be equal for the first first object, and let's do some changes in the second one. Okay, what I'll do is I'll have more within these frames. I'll not make it go that far. I'll squish this in a little, so that this spacing is increased and we have more frames here. All right, so this will be slow, this will not travel that as much as this is traveling, and then it will pick up, and here I want to make it reach. Okay, I'll squeeze these frames in. Okay, this spacing, I'll reduce this spacing so it is slower in the end. Basically what I'm doing is giving it manual ease in and ease out, but you'll get the idea. Now the spacing in between, in the middle, for this object is more than this one. Okay, you can see that, I guess it's pretty visible. Alright, so this will travel faster in the middle and then slower. Okay, let's check that. Alright, and if I just smooth these curves, then it is much more. Now you can see that the animation for both the objects is 1 second, but how we distribute the spacing will define what kind of animation it is. Okay, so let's say I'll remove this. Let's say it is going with the same speed but easing out, it's reaching faster. So let's make it reach much faster here. Maybe on the 18th frame itself it will reach and then it'll settle. All right, it's basically overshooting a little bit because of the curves, but let's not mind about that. So you can see the spacing is very equal here, and here the spacing is larger, and then it we squeeze it in together. Okay, now you can see how we have affected the timing. Okay, the timing is not the length of your animation, all right, it's how much frames that you give for that object to travel from one place to another, how much frames and how much spacing that you define for it, and that will work out to be the timing of your animation. Okay, so I can say that the timing of this ball is faster than the timing of the white one. Okay, so that's how it works. The any hand gesture that your character does, or a walk or a head turn, how much frames you are distributing, how much frames you are giving to that action will define the characteristic of this action. If I'm like a sloth and I'm turning my head very slowly, then the timing is slow, of course. But if I'm like a squirrel and I have to be quick, so what I'll say is we need quicker timing on that squirrel. All right, so that's how the language of animation will work out to be. I hope this clears up the principle of timing for you.